2015 25 March statistics question. A survey of 100 shoppers selected from a large number of Saturday supermarket shoppers showed that the mean was 90.45 of what they spent and the standard deviation was 70.23. So we're asked to find a 95% confidence interval for the mean amount spent in the supermarket that day. So 95% confidence interval is 1.96 multiplied by standard deviation over root n. So 1.96 by 20.73 divided by the square root of 100 is going to give me 4.06308. We'll just take 4.06, it'll be fine. So I got to take my 90.45 and I got to add 4.06 and I got to take away 4.06, so 94.51 on one side, and if I take away 4 I'm going to get 86.39. This is my 95% confidence interval for the mean amount spent in the supermarket that day. The supermarket has claimed the mean amount spent by shoppers is 94. Based on the survey, test the supermarket's claim using a 5% level of significance. The mean is 94. Well, H1, the alternate hypothesis, the mean is not 94. And we are testing 90.45 against this. So 90.45 based on the survey, test the supermarket's claim. So we're basing this on the survey, so we're saying that the average is 94 and we're testing 90.45 against that divided by standard deviation over root n. So my standard deviation was 20.73 over square root of 100. And that gives me minus 1.71. If you tested it the other way around, that way you would get the plus 1.71. It's not going to change the answer here and wouldn't be marked incorrect in an exam. So we can say as minus 1.71 is greater than minus 1.96, fail to reject H0. And part C, find the p-value in the context of this question. Okay, we need to look up 1.71. 1.71 is 9564. So what we can say is, in my tail, here in the minus part, we have 0.0436. 0.0436 or 4.36% times 2 is 8.72% or 0.0872. Write both, you don't know what way they could ask for it specifically. So the p-value is both tails, that's why we're multiplying it by 2. And in the context of this question, as our p-value is greater than p-value greater than 8.72%, sorry, greater than 5% at 8.72%, we fail to reject H0. P-value less than 0.05, we would. You don't need to write this, but you know that we would reject H0 if that was the case.